All right, since it seems like I'm never going to see you guys in person ever again, it's such a depressing thought. I am doing this via video to keep us moving so you can take the test next class, okay? So the first video here is gonna just be over target 6, and I will make another video for target 7. And so the things that you need are your review or your own sheet of paper and your orange foldable. You like how I highlighted that orange so that you could correlate? All right, so this target is I can use half angle and double angle identities. Okay, so the first thing we're going to do is use half angle formula to determine the value of sine of 11 pi over 12. Now, most of us do not work well with fractions. If you work well with fractions, you're going to double that fraction, making it 22 over 12, which reduces to 11 pi over 6, and you're going to work from there. For the rest of us, we're going to take out our old knowledge about making radians into degrees by multiplying by pi over 180. So remember, multiplying by pi over 180, or 180 over pi, I'm sorry, 180 over pi. So I'm going to do 11 times 180 divided by 12 is 165 degrees. For most of us, that makes more sense. So really, you are finding sine of 165 degrees. Now, look at your unit circle and you'll notice 165 degrees is not it, right? Like it is not on there. However, if I double 165, I get 330, and that is on the unit circle. So maybe instead I can find 330 degrees divided by 2. Now careful, that does not mean that I just take whatever 330 degrees is and divide by 2. No. That is not what it means. Okay, instead, I'm going to go over here to my half angle formulas. And I notice that sine of alpha over 2 equals plus or minus square root of 1 minus cosine alpha over 2. So I'm looking at that first one there, okay? So equals the square root of 1 minus cosine. Now I'm not going to use alpha. I'm going to use 330 because that was double the angle I'm looking for, divided by 2. Okay. Notice there was a plus or minus there. Here's how you handle the plus or minus. So take a pause from everything we're doing here. You're going to look at 165 degrees on the unit circle. And you're like, it's not on there. I know, but it would be somewhere right here-ish, right? If it were. Notice sine, which is the y value in this quadrant is positive. So therefore, sine is always positive in quadrant 2. So that's how I know that this answer here is positive. Okay. So now I'm going to use my unit circle to figure out what cosine of 330 is. So 330 is over here. Cosine is the x value. So I'm going to put square root of 3 over 2. In that corner. So it becomes 1 minus square root of 3 over 2. I will zoom in because I'm sure that's tiny for you guys. And that square root should actually be over the entire thing, bottom to top. That's important. Okay? So from here, it's just algebra, but that is unfortunately easier said than done. So first thing I'm going to acknowledge is I'm going to change that 1 here to 2 over 2. That way I have a common denominator. Okay. And then instead of making that long bar with the 2, I'm going to actually go old school here and do the divided by 2. Okay. So that is 2 minus radical 3 all over 2. And when I divide by 2, that's the same thing as multiplying by 1/2. Which then multiply top by top, so the top stays the same because it's being multiplied by 1. 2 times 2 is 4. Okay, last step. What is the square root of 4? Well, that is 2. The top stays crazy like it is right here. Okay? All right, so that is half angle formula number 1. We're also going to look at what to do with tangent. Remember, tangent's always weird, but again, it tells you what formula to use. Okay? So tangent. Now, notice there are 3 different tangent formulas. Okay? I personally would choose the ones without the square root. So either this one or this one. And honestly, 9 times out of 10, I'm going to choose this one in the middle. Simply because I do not have any type of adding or subtracting happening in the denominator, which is where crazy things start to happen. Okay? So remember, we actually want to double that. So 175 doubled is 150. So tangent of 75 degrees is equal to tangent of 150 divided by 2. Okay, notice, think, critically think, don't just write down what I'm doing. 150 is double 75. So if I write 150 divided by 2, it's the same thing. Okay. Now, using that formula over there, so I'm going to write small for just a minute so that you can see it. 1 minus cosine 150 divided by sine of 150. I'm going to do that for the math here. Okay, so at 150 degrees, again, my x and y value, I'm just going to write it here at the top of the page so I don't lose it. So my cosine and my sine values are right here. So I'm going to fill that in. So I have 1 minus negative radical 3 over 2 divided by 1/2. And of course, that looks super messy, which we don't like, right? So I can make that 1 a 2 over 2, just like I did in the last example. I'm going to make that plus square root of 3 over 2. And then just like last time, I'm going to do divided by 1/2. So then I get 2 plus radical 3 over 4. No, I don't. Over 2. Forgive me, it's late according to my standards. I know 8 p.m. is not late for you guys, but it is for me, especially after I've worked all day. All right, so divided by 1/2, I'm actually going to times by 2 over 1. So that's going to cancel. And I'm left with 2 plus radical 3. Remember, work smart here. You can type in tangent of 75 into Desmos. So type that into Desmos. It's going to give you a crazy decimal. Make sure you're in degrees. Okay? Then you're going to type this into Desmos, 2 plus radical 3. And it should give you the same crazy decimal. If it doesn't, you've done something wrong. That's a way to check your answer. You can do the same thing here. Type your answer here into Desmos. And is that the same thing as sine of 165? Or if you're in radians, you can also type in sine of 11 pi over 12. You just have to make sure you're in radians there. Okay? All right. To me, those are the harder questions. Half angle is weird. Weird things happen. You have to remember lots of things. Okay? Next, it tells us we're going to use a double angle formula to find the exact value of cosine of 2a. Okay? Cool. We're going to leave that alone for a second. We're first going to deal with this part right here and dissect what that means. So remember that 3 pi over 2, so if you need to look at your unit circle, please do. 3 pi over 2 and 2 pi. That means we're actually in quadrant 4. So I'm going to draw myself a triangle in quadrant 4 like I did in unit 3. Okay, And since tangent is opposite over adjacent, I'm going to make the opposite here negative radical 35. And I'm going to make the adjacent 35. Again, use logic. This is your x value, and your x value is going positive. So that's how I know the 35 is positive. Since this is going down, that's how I know that's negative. Okay. Then I can do Pythagorean theorem. Forgot that name. Don't know how I forgot that name, but I did. A squared plus b squared equals c squared. So that's going to give me 1225 plus 35, and that's going to equal c squared. So that's 1260. Easy math computation there, nothing hard. Now, the answer is the square root of 1260, but that is not simplified form. So thinking back to 7th grade, how did you simplify radicals? Well, way one is to just know, yes, I do mean that 36 times 35 is the same thing as 1260. And that, hey, the square root of 36 is 6, and then 35 just stays because 7 and 5 are its factors, and that's all there is. Okay? Now, most of us, our brain does not do that way. So what I do is make a factor tree. And then factor it all the way down. I know that that is even, so that would have to be 63, 9 and 7, 3 and 3. Okay, so my list of factors there is 2 times 2 times 3 times 3 times 5 times 7. Okay, I have a pair of 2s. They're going to go to the outside. I have a pair of 3s. They're going to go to the outside. And then these are going to stay home. So I get 6 square root of 35. Either way I do it, I get 6 square root of 35. Okay. From there, you're going to look at your double angle formulas, which are right there to the right. Now notice cosine has 3 different ones, so it really does not matter which one you choose. So let's say that we do cosine squared alpha minus sine squared alpha. Again, does not matter. Does not matter. Okay, if this is the one you choose, cosine is adjacent over hypotenuse, so the adjacent is 35. The hypotenuse is 6 square root of 35. Okay, sine squared alpha is opposite over hypotenuse. And then we're squaring that. Okay. Now, you can do that by hand. You can do some math. It works out okay. It's not too bad. Or to save us a little bit of time, just type that straight in Desmos as is. And you should get 17/18 as your answer. Okay. All right, last one, verifying an identity. So remember, the goal is to get the left to look like the right. So I notice that I need sine of 2x. Well, sine of 2x is equal to 2 sine theta cosine theta. So if I go back and look, oh, I already have that part. Cool, I can do that. That is easy. Done. I'm one step closer. So now, I'm just going to go ahead and take this down. I need to change something here so that hopefully some things cancel, where I am left with just this, because that's the part I'm missing. So 2 cosine squared x. Why does that matter? Because if I go and look at these double angle formulas, you're going to notice there's 3 different ones to use for cosine 2 theta. But I know that my final answer, I only need cosine squared theta. So I'm going to choose this one here that says 2 cosine squared theta minus 1. And then I'm going to bring down this, and I'm going to bring down that 1 from the front because I can't just make it disappear. Okay, and then I look and I have 1 minus 1 cancels out. Hey, I did it. Yay! The left is now equal to the right. I'm going to put my little square to say I'm done. And I have verified that identity. So that is what you're doing for all of topic 6 or 4.6.